All right.
Right.
This meeting is being recorded.
Can you host? Like, can you present as well, like the agenda?
Yeah, sure. 1
I
second.
can.
Yeah, I'm just back from sending my kid to the summer camp. 1 second. I'll share my screen. All right. So yeah, welcome to this week's SIG schedule meeting, and this meeting is being recorded. So be respectful to each other. And the first item in our agenda is Vinay and Chen. Finally, we have the in place path vertical scaling for 125 to merge. And Vinay, we don't want to give an update.
Yeah. Hi guys. So I think we are getting pretty close this time around. Fingers is still crossed. But 2 days ago, we had the SIG node meeting, and Derek and even the maintainers of CR Cryo and Containerd seem to be pretty optimistic that it's pretty close. The main thing that was that it slipped from 124 to 125 is we just didn't have the cycles to get the review with Derek and all the items fixed within the time and have sufficient, buffer for any potential, snafus. But scheduler code hasn't really, the changes that I made, what I last committed, there were some issues that Wang Wei found, and I have addressed them. The last commit was in January sometime, and I've been updating it to keep up with the rebasing, but the code itself has not changed. I don't believe I've made any updates to scheduler code in a long time. So what is there currently should address most of the issues that were raised for the scheduling side, except two. And one of them is about optimization, which I think last time we met, we kind of figured that one of you would be able to look into that. I really haven't had the cycles to look into it at all. And the other one is adding some kind of tests for different states, the resize status that might be generated based on the situation on the node. For example, if the pod is, if the node does not have any capacity to allow a resize, or if the resize requested is more than the node's available resources, it's going to set it to infeasible. And a pod that may be requiring you create a new pod that's asking for that, then it's going to be in infeasible state. Perhaps, and then when a pod leaves, that pod should get the resources it needs. I don't know if that kind of fits the test that we had to look into what exactly that test does. And we were wondering if that is something that can come in. We're looking into it, if that can come in after the merge.
Yeah, I need some time to refresh my memory on my previous review on that. And according to the current change set, I think there's one piece missing is the integration test. So I like some, at the minimum, 1 or 2 integration tests to connect the dots to simulate a full scheduling cycle to see how the case is like. And maybe it needs to, I'm not sure, there is some controller running there to change the status or something out there, so that I don't think it's just one cycle. It's just maybe 2 cycles. Some components update the status like infeasible or something. Then the scheduler gets acknowledged and finish the whole loop.
Yeah, I think that's so. Instead of integration test, we were thinking if this could go into a E2E test, because it seems like a good candidate for this. Let me post. I can update the thread as well, but I'll post something in the chat that we were discussing.
Yeah, if it's kubelet update the like infeasible status or something, then I think yes, integration test doesn't fit. I think in my previous comments I just mentioned integration test or end-to-end test.
Yeah,
we
you
just
did.
need to, yeah.
So yeah, that's what we were planning to add E2E tests because we already have a lot of the E2E tests in there, and it's going to run on a pretty much a local cluster, but that's more realistic. The components are all there. And let me just share one thing in the chat here.
Okay, let me stop
So
sharing. Yeah, you can share. Let me make you co-host.
I was just going to put it in the chat, so
okay.
it's you to read then. So this is like a very bare bones. There are probably a couple of different variants of this we can do, but let me just walk through that. So if you have a node that has, say, 2 pods, P1 and P2, and one of them is scheduled and running, and the other one is unschedulable because the request that, and this is going to be sitting in pending state, the scheduler is not going to assign a node to it because the local node doesn't have enough room for it. And then we change, and it's never going to get assigned until the pod leaves, right? P1 leaves. But if we modify P1 so that it's goes through the transitions of pending and then or in progress, and then it finally comes down to the updated, and then P2 should get scheduled. Is this something, a test case that would fit the needs of what you are looking for?
So basically, I want to see at least 2 cases. Like one is, okay, the pod is scheduled, and you request a resize.
Yeah.
And the resize is to, okay, it's not possible. So it gets some components updated as infeasible. And
yes.
Yeah, this is one case. The other is okay, this is feasible, and then see how the scheduling changes accordingly.
Sorry, yeah, go ahead.
Yeah, so yeah, the other case is feasible, and see how the scheduler behaves accordingly. And another case I have in mind is, okay, it's the unscheduled part, maybe because it's requested too many resources, and then it resize, it's shrink down the request and see how it works.
Yeah, that is the case I thought was probably more relevant to the scheduler. At this point, if a pod is scheduled and running and you request something, the whole design is based on, okay, the scheduler is not, it's just observing. And in the future, the scheduler may, choose to schedule some pods away from that node because there is a resize. There is infeasible is going to be infeasible. You can't do anything about it because the node's never going to give you the resources. So if you have a case where the node has, let's say, 4 CPUs to give, and you start the pod with 2 CPUs, but then you come and say, oh, okay, 2 is too less, I need 5. The node's never going to satisfy. The only option that you have is to nuke it and send it to a node, have a new incarnation of the pod get scheduled to a new node where you can get 5, right? So, but if it says I want 3, and there is another pod that is running over there that's taking like another 2 pods running on that node, which are using 1 CPU each, then and one of them leaves, the scheduler may say, okay, there is a resize pending here. I'm not going to try and race to that by assigning a new pod that's coming in and asking for 1 CPU. I'll let the resize happen. We probably already do that now by using the max. That is the case that I think we can exercise and see that it works. Does that answer?
Yeah, that makes sense. But note that why I want the scheduled resize case, I mean, the resize of the scheduled part of the case is that I want to ensure the resized part hit the regular state scheduling code logic so that inside the scheduler, that path request get refreshed. So it's not get it scheduled or unscheduled. It's just to ensure the internal cache get updated accordingly, so it doesn't cause any
I see that.
unexpected behavior.
Yes, I have verified that by logging it using logs.
Yeah, for example, we can craft a test case like one node has 4 CPU.
Yes.
And then we have a one part request a 2 CPU, which has already been scheduled, right? Then
Yes.
we resize the pod to like a 3 CPU or 3.5 or 4 CPUs.
Yes.
And then we spin up another pod request 2 CPUs and check whether it's schedulable. If it's schedulable, that means the cache wasn't updated.
Yes.
So that's the point I want to make.
Okay, I think we got that. So, Wang Chen, do you have any questions about the case that Wang Wei just talked about? I think this is a very, very relevant case that we can, it doesn't depend on timing. I think the main thing that we were looking at is if we were to try to write a test case that, tries to, one pod is resized down and you create a new pod, unless you have like tight control over the timings of how this can be done, we can't verify that max. The whole reason why we have that max is so that it's conservative. It's going to let the resize, it's going to give the resize priority. So, and that's only supposed to be done when the state is not infeasible, right? If it's infeasible and you're allowing the resize to take up, hold up resources for that another pod could be using, that's gaming the system. So that's the change in scheduler that we have. So there are a few test cases here. I think what you just described is a test case. Wang Chen, please let me know if you have any, or please ask if you have any questions.
So, yeah, I just want to have a brief summary of the total number of testing cases we have, right? So in addition to those two you already described, could we summarize a little bit what is the third one?
I think the third one, the case that Wang Wei brought up was you schedule, let's say, I can take this offline with you, but let me briefly repeat it so that it's clear to me as well. Take a node that has 4 CPUs and you have 2 pods there which require, which are taking up P1, P2. So P1 is taken up 1 CPU, P2 has taken up 2 CPUs. So there is 1 CPU capacity left, isn't it? Now, if you create a pod, a third pod that's asking for 2 CPUs, it should remain. It should remain in. No, you cannot schedule it because there is not enough resources, and you nuke one of the pods. Either one doesn't matter. Then it creates a capacity to have or resize one of the pods. Not nuke, but resize one of the pods to reduce it to 1 CPU, the P2, make it 1 CPU. Then the scheduler should go and should schedule this P3. That shows that the cache was updated. That's what Wang Wei is looking for. Is that correct?
Exactly. Exactly. Okay.
Yes, but what's the difference between the first one, which is like the first one you described, P1 and P2, and P2 is pending, and then update P2.
It's the same, I believe.
It's not exactly the same because internally inside scheduler, we have different paths for dealing scheduled pod versus unscheduled pod. So one is in the cache, one is in the queue. So we want to ensure they just hit the regular path properly.
Okay.
So just ensure the code coverage.
I see. Okay.
So I think adding a third test case of what we described with 3 pods is not. Once we get the basic test case running, we should be good on that. About the timing of this, is this a blocker for you to sign off on not having this test? Because the code, the bulk of the code changes that are there are in API and in the kubelet, and checked with the Derek as well to see. He's looked at the scheduler code as well, and he said, yeah, I agree that the changes in the scheduler are pretty are minor. We can he's okay with it. He's good with that. He's got a few questions around, there outstanding questions that are there around defining the runtime expected runtime behavior, which I think there is slight fog around what the runtime should do when it gets a resize request. But we're hoping to clarify that. I mean, I disagree with a little bit with how the cryo wants to handle it. They want to cache it and report the cache value. I want the actual values. So we're going to sort that out in the next week or so. But we're hoping to merge this pretty soon. what we wanted to get from you is a pulse of how do you feel about merging this? If we don't have the time to get this E2E test in, are you still okay with merging this scheduler portion of it, or you want that E2E test? We'll do everything it takes to get it done before the code freeze, of course. But let's say the rest of the code is ready to merge in a week or two. Then are you okay with signing off without the E2E test being there, this particular test, these 3 test cases that we discussed today? Or do you want this as a blocker for the scheduler side?
Once we have like issue tracking the to-do changes out there, so I'm fine with just merge the pair scheduling changes along with the unit test. Then we must do a follow-up on that. So I don't want it to block the whole giant PR, which went through several release cycles.
I have various terms to describe this. It's like rebase cycles from hell, and pushing the boulder up the hill. So it's I think I would do things a little bit differently. I wish GitHub provided something like a linked PR feature or something where you can have these different PRs that are separate, but they kind of chain together, and until the head PR goes in, the others can't go in, but they can be approved LGTM separately, as long as because you're only looking at code and they need to build. And well, okay, I'm gonna.
I have a quick question about the semantics of this change in the scheduler. So when you get a request to change the size, change the resources, the pod becomes both, like it's stored both in the cache and the queue. It would have an instance in both places, because you need to keep trying to admit the resize. I'm just trying to understand, like, how is this semantically?
Does the resize, if a pod is scheduled, does that ever enter the queue in the scheduler?
Well, that's my question to you. Like, how do you try to admit the resize, like accept it, or is it on the kubelet to accept it?
Yes, it's on the kubelet. So this is the earlier design that we had. I presented a earlier version of the design in KubeCon Barcelona a few years back, and at that time it seemed like a good idea where the scheduler is going to approve. That's gonna it prevents race conditions. That's the reason we came up with that design. But then later on, the thinking changed. We already have this facility to have multiple schedulers, and if somebody brings in a third-party scheduler that runs alongside the scheduler that K8s we provide, then we still don't have control over that race condition thing that we're trying to solve. So once a scheduler assigns a pod to a node, it should strictly be a business between the kubelet and the user as to whether your
right, but you still have the race condition between the kubelet and the scheduler, even if you have a single scheduler. Like if kubelet decides to admit a pod and the scheduler at the same time is trying to schedule a new one,
yes,
you will have that. Okay,
yes.
and we are accepting that.
Yes, today we already have that, and the final gate, the final say the gate is the kubelet, because kubelet knows what it can give or not give, and that's the ultimate judge and authority for the admission of a pod. So in the end, I think it calls the scheduler's fit routine, fit predicate, pod fits node, right? And that's I believe that's common whether for scheduler as well. Scheduler uses its cached values, where kubelet uses what it has against measures the pod. So briefly, what happens is that you have, let's say, 3 pods, P1, P2, P3, and P1 wants to resize. So what kubelet does is it says, okay, I have this node with capacity X and P1 plus P2. So P2 plus P3 is taking up this much. I'll remove P1 from the queue, measure what it needs with the new resized value, and then it's as if it's admitting P1 at a brand new. If that answer is no, you don't fit, then the resize is denied. The pod still keeps running at its current levels, but its resize is denied. That's the idea. Well, it kind of gets into like deferred or infeasible. That's what it ends up looking to the user who's observing, and that allows the the user to take actions. It's a summary status. If it's in progress, then they know, okay, it might take a little bit of time for the runtime to actuate and get me the resources that I need, but yeah, everything is going to be okay. If it's deferred, then they have to make a decision. Okay, how long can I, if it's CPUs, I'm running suboptimal CPUs, that's great. I can deal with that. If it's memory and it's deferred, I'm going to run out and I'm going to get killed. So I might as well just be proactive about it and nuke it and start it up on a new node. It's a policy thing. They can choose. We have policies. They can choose that. I'm talking a lot, sorry, but the idea is the summary
No,
is
that's
that
okay.
it's
I
a
guess
business between.
yeah, this is summary is that basically the kubelet is the one that is partially taking the job of the scheduler. And
It's not exactly taking the job of the scheduler in that sense. It's
well, it is assigning resources to a pod, right? That
yes,
scheduler didn't assign beforehand. So
it
in a
is,
sense,
yeah,
it is
it is,
acting as a scheduler.
yeah. That's the reason our initial design kept scheduler in the loop, but that was complex and it ended up becoming, sort of it was introducing a quasi state machine, which is, problematic.
I didn't mean to rehash that discussion. I was just trying
Yeah,
to refresh my memory how this works with this
yeah,
scheduler and
yeah.
why would the schedule changes be so minimal as like Derek mentioned. I didn't look at the PR.
Okay, yeah.
So that explains it. Like if the scheduler is basically reacting to what kubelet is telling us to do, then it makes sense.
Yeah, I think the scheduler, there is definitely a possibility for race, and by using the max. So when since both are watching, when a API server posts there's a watch event triggered, it could three cases happen. Scheduler sees the watch before the kubelet, everything is good. They both see at the same time, everything is good. Kubelet sees it first and acts it, and scheduler hasn't seen the watch yet, in which case it might try and schedule a new pod to that capacity. And kubelet will, tell it, uh, you know, do it, try again. So that's happening today anyways with multi-schedulers. So that was the idea. Does that clarify?
Yeah.
Clear any fog? Okay. Okay. So it does sound like we are in agreement with the.
One warning. Please make it front and center that this race condition is going to happen in the documentation.
It's already there in the cap. I will put it in the documentation as well.
Yes, in the documentation, because not everyone runs more than one scheduler. And the issue that I see is that one workload could affect other workloads that might not be ready. So if someone decides to suddenly start using vertical pods scaling,
yeah,
in their workload, they are aware of that, but maybe their neighbor is not aware of that. So
yeah,
so the cluster administrator needs to be aware, and maybe they want to prohibit this some of the users to using this. So yeah, make sure that then.
Okay, so the to-do items that you're capturing in that, I will put it into an issue at, so I do have, let me just share one link with you. I'm tracking all the outstanding issues that are that need to be addressed, and this is what I'm using for also seeing who's working on what. This is where I'm tracking the issue for scheduler changes as well. And I have not marked it as alpha blocker at this point. I hope that's okay. We the 110490 E2E test and beta blocker issues. But the goal is not to, of course, not to wait until we're getting to beta, but before this code freeze, we want to try, and that's it. That's what we're shooting for with this test. There is a couple of items in the one of the item with the resize test is that it is currently located in a path that is deprecated, and we need to move it from E2E /node to another location called E2E node that has a little bit of a different framework. As we do that, we'll probably take this up because otherwise we'll have to repeat a bunch of work for the new framework.
Then should we put the same all the E2 test related scheduler also in our original testing folder?
Oh, I think we need to move it to another folder. That was Daniel's request. So I'll start looking into it. I'm wrapping up a few other things that I was out for the last 2 weeks for a conference. We both were.
Yeah.
And we just got back and started looking into this. But yeah,
Okay.
the summary is that from API perspective, Tim Hawkin has already approved it. And Derek has, look, he seems to be, at least the sense I got 2 days ago was that he's very close to LGTMing it. Just wanted to make sure that scheduler is good so far with what currently is there.
Yeah, I have a question for Wei. So does that mean if all our scheduler plugins are not aware of those this in-place update feature, then if we have a secondary scheduler in the cluster, then it will definitely cause the racing issue.
I think the most relevant, it quite depends on how your out-of-tree customer plugin is developed, right? But to my understanding, the most critical plugin that interact with this plugin is the no resource fit plugin, as well as the internal calculation logic, like how it calculates the request consumption in the internal cache. So I will see very minor impact on the existing out-of-tree plugins, unless you have very particular in-house logic dealing with the request magic sort of like that. Other than that, I think it's good so far. Yeah, because this plugin only involves the resource calculation, right? Other than anything other else.
Yeah.
Yeah. So if your plugin is not involved into a very specific logic of calculating the resources, then
The allocatable resources, you mean? Okay.
Yeah. Okay. So I think is there any questions on this? I think we have reached a basic consensus that we can give a green light on this. But Abdullah and Aldo, if you want to take another look, you're feel free to do that. And the next thing is we want to list some to-do items out here, either documentation or the pending entering test. So we will review that after the PI is ready.
Yeah, sorry, I was just going to say that I'm going to lift these to-do items and then create a new issue for documentation. To track it and make sure it gets in.
Yeah, thank you for your diligence on this. And okay, next item is idea that we may want to map each scheduling profile to some particular namespaces so it can reach the best extent of the reuse. So I'm not sure Yan is online. Otherwise,
yeah,
maybe
Yan is not here, but I can fill up.
Okay, sure. Yeah.
So I think I'll talk about the use case first that we have, and then perhaps what do you think should be done. I also looked at what Abdullah suggested. It sort of makes sense, but I want to get to the fundamental question here. Why do we need to have profile name being matched to the scheduler name? Why can't we have a single scheduler name mapped to multiple profiles based on the namespaces, right? So like, I think when we started with the scheduling framework, we have this backwards compatibility issue. And I think I could be wrong. This is the reason that I can think of, that we have the mapping. But what we are thinking of is, now I'll talk about the use case. So we have in OpenShift, we have this self-hosting. OpenShift runs as a self-hosted platform, meaning we have a Bootstrap control plane, and we have the control plane that gets created after the Bootstrap gets deleted. So the entire control plane components would have certain weights associated with them, like for particular profile. For example, taints and tolerations would have an additional weight, or some other component, some other plugin would have additional weight, and some of the plugins may not be needed at all. And all those control plane components run in a particular namespace, which starts with OpenShift dash. So what we are thinking of is, can we actually leverage it to make sure that certain plugins are enabled only for certain profiles, instead of having to change the scheduler name altogether for the control plane components. I hope it is clear till now.
Yeah, I mean, but it's still like, we do have something similar on GT, and the idea here is to really like simple as setting up a webhook, right?
Yeah.
To say, okay, this pod is matching X namespace, then I'm going to set the scheduler name to X, which is equivalent to the profile. So there is a path to implement what you're looking for.
Right.
And I feel it's a reasonable path. It's not like, complex, and it fits the webhook, mutating webhook, what we need, what we can do with mutating webhooks, because what you're changing is really simple. Decision that you're making based on this change is also simple, so it's not like going to add too much overhead on the pod creation path. My concern here is not just like I'm like pushing back on this just because we have a solution, but also because I mean, we've built the idea of profiles. We have metrics, etc., all like attaching the profile with a scheduler name in some sense. I'm concerned that if we change that association, we're gonna stumble into bugs. That I don't see an urgent need to do this, because there is a really clean and reasonable solution for that use case outside the schedule.
So to be clear, would you run another scheduler in those cases?
What do you
like
mean?
Say if the webhook modifies default scheduler to scheduler ABC, would you run another scheduler ABC with the set of plugins?
No. It's one scheduler. You just set the scheduler name to the profile. But that's the whole thing, right? Like, you can create multiple profiles under the default scheduler, right?
Right.
And it's basically, each profile is basically a scheduler, right?
Right. But I'm confused with the naming. Like, you are telling that the scheduler name would match the profile name, right? Or
Yeah.
Is it not the case?
Yeah, it is.
Okay. Then
so
perhaps
basically, you create your pod. You don't set the pod is scheduler name at all.
Right.
When you create the pod, it's the webhook that will decide what scheduler name the pod will get based on the namespace.
Right. And what are the concerns that you have mentioned? Can you
complexity? Like the change that you're proposing to add to the scheduler doesn't seem to be justified, given that we have a solution for this. Like, why push it down the scheduler?
Yeah, I think you also mentioned about some of the metrics issues, right?
No, I mean, like, what I'm trying to say is, like, it is related to the complexity. Like, we've created metrics that basically, like, there are a bunch of things that are associated with the profile name, right? Like, maybe Aldo can speak to this.
Yeah, I think just I want to raise another point is that, so basically, if we introduce the matching namespace here, we are just assuming that the multi-tenant tenancy is based on namespace, but in fact, it can be more complex and more dynamic. So if we just use the admission webhook to control this kind of layer of logic, that will be more dynamic. Like if you're running a virtual cluster, you have another layer of your virtual clusters. That virtual corresponding to a tenant. You want that tenant to use this kind of plugins that will be more dynamic using the admission webhook solution instead of the hard coding the namespace here. So that's my opinion.
Another side concern is that surely you have this need today, and then since because you add this field, someone comes with a different need that is based on, I don't know, labels instead of namespaces. And then we end up with an API that's even more complicated. And as Abdullah was saying, yeah, you can already do it through webhooks.
I see. I think the concern is more on the lines of the use case may not be generic enough. And we can, in fact, improve the logic if it is outside the core. Say if the choice of separation is not namespace, but if it is something else.
Right. Yes.
All right, makes sense. Let me think about it, and then I'll get back to you on it.
Another example we're doing it, for example, with Jiki is, or maybe in the future, is per node pool, for example, like specific pods. If you say, okay, I want to schedule this pod on this node pool, which I want to be, bin packed. So I create this profile that is, more aggressive in bin packing. So we base our decision on where the scheduler is going to be, like on which partition of the cluster. So it's not related to the namespace, it's related to which partition of the cluster that the pod is intended to be scheduled. And so, yeah, I mean, there are many examples that we can give. And here we're just like basically enabling one specific thing, right? Like namespaces. And as we mentioned, there could be a lot more. And so using a webhook is reasonable way of doing these kind of things outside the scheduler.
Yeah, so my concern was more on the lines of two things, as I mentioned earlier. The first one is, was it done just to be backwards compatible with the scheduler name? Number two is, like, as I told, it is pretty much simple to do it in the core at this point of time. So why to go with webhook? Those two were my concerns. But I think I understood the reasoning that you have.
Yes, the scheduler name field already existed, so we used it. And basically, what we achieve with profiles is to have a single scheduler look like multiple schedulers. That's the rationale. So it fits the name. Even though internally we call it profiles, it actually is kind of like a different scheduler. So that's the logic. One more thing, I know the SIG API machinery is working on webhooks, mutating webhooks support through Cell, which is a language you can upload to the API server, and then the API server can apply the logic. So in the future, this kind of webhooks could be very fast.
All right, yeah, that's all I have then. Thank you.
All right, thank you, Ravi. I think that's basically all the items we want to discuss today. And if anyone has any other things, please raise that.
Hey, a question about the descheduler, if there's still anybody online who knows about it. So it's going through a big refactoring at the moment. I was just curious if anybody would have an update on the timelines of that, because it's being architected into a plugin-based model the same way as the scheduler is.
So Mike, are you able to answer
Yeah,
that?
Mike would have been the man, or Jan.
I'm sure Mike is in the meeting today.
Not anymore.
Okay. So yeah, maybe just asking this question in the
I guess I have to ask on Slack.
channel.
Yeah, I'll try Slack.
Yeah, apologize for that.
Just a quick clarification on the metric thing. So I guess my point here is that, like, in the scheduler code, we use the scheduler name that is set in the pod spec to, for example, when we record some metrics related to the pod, one dimension of those metrics is the profile name. And so if the scheduler name, like that would require changing these places, right? Like the assumption that the pod is associated with profile X by accessing the scheduler name field. With this change, basically we're detaching these two things and we have to carry the profile name in some other field, right?
Yeah, so I want to separate it out, but it will still be part of profile is what I was thinking. Like there is a sample config that in the issue itself that Jan has created. You can see that there is a scheduler name in the profile.
Right, but like in the current implementation, the profile name is in the pod spec itself, right?
Yeah, it's in the pod spec directly.
So which makes it easier. And it's basically everywhere in the code, we make that assumption.
Yeah.
Thanks.
All right. Thank you everyone for joining today's meeting. We are just in time, and yeah, we will see you in 2 weeks. Yeah, have a good day.
Thank you. Bye.
Bye.
Thank you. Bye bye.